Kia ora, Year 12 and Year 11. This is question 2 from last year's probability methods exam. It's quite a long question and it's quite hard. It's got 2 tricky excellence parts. I'm going to do it all as one long video. So grab your pen and we're going to start with a tree diagram. So the question is all about sheep and merino ewes and lambing behaviour. So read it really carefully. Merinos that produce lambs usually have either single lambs or twins, and multiple births other than twins are extremely rare. So we've got a long-term study showing that 65% of merino lambs that produce a lamb will have a single, and out of those, 86% will survive until weaning. Of the ewes that produce twins, 1 in 5 lose both lambs before they're weaned, but roughly equal numbers of 1 or 2 twins survive until they're weaned. So we have to first of all find the probability that a ewe gives birth to a single lamb that survives until weaning. So we're going to start off with a simple tree diagram. So this first one is going to be, let's see, single, and here we're going to have twin births. This one's going to be 0.65, and this one is going to be the rest, 0.35. Now, if they have a single lamb, 86% survive, and the rest don't. But if the ewe has twins, then we have 3 options. 0 survive, 1 survives, or 2 survive. We can put the probabilities on here. We've got 0.2 here, 0.4 here, and 0.4 here. Okay, so I'm doing that because we're told roughly equal numbers of 1 or both survive. So the first question is to find the probability that a ewe gives birth to a single that survives until it's weaned. So that works out to be, we're just following down this branch, so 0.65 times this one here, 0.86. So probability that it's single and it survives will equal 0.65 times 0.86, which works out to be 0.5 something. Just let me grab my notes. Yep, so that's 0.5590. Okay, so far so good. That's an achieved question. The next one is similar. We're asked to figure out the proportion of ewes that give birth to twins that both survived until they're weaned. So again, using the tree diagram, we're going down the twins one, and then we want the bit where both survive. So that's going to be 0.35 times 0.4. And that gives us a probability of 0.14. So both of those are fine. They're pretty typical achieved questions, and this is where it starts to get a bit more interesting. So now we have to figure out the probability that a randomly chosen lamb that survives until it's weaned came from a ewe that produced a single lamb. So we can think about doing that with our tree, but we've got one thing that's going to make it go a bit wonky, and that's that down here we've got 0 lambs surviving off that branch. Here we've got 1, but here we've got 2 lambs surviving. So that's the tricky thing, I think, in this question. We've got to figure out of the lambs that survive, how many came from ewes that had a single lamb up here. So I think a better way to do this is to do a table, and let's think about 1,000 births. Okay, so we've got 1,000 ewes, and we'll think about how many lambs they had. Well, we know from our tree that 650 of them had single births. So that's pretty straightforward. And of those single births, how many of those lambs lived? Well, it's going to be, put our 350 here as well, 86% of 650. So that gives us 559 lambs. I'll put L there. And sadly, the ones that didn't survive, so that's going to be the rest. So that will be 91 there. But we don't need to worry too much about that. Now, looking at the 350 ewes that had twins, we're going to break them into two groups. We had 40% of those, so 0.4 of the 350 had twins and one lamb survived. So that gives us 140 lambs. But 40% of those 350 had twins and both survived, so that gives us 280 lambs. So altogether, what we've got to figure out is that what's the probability that a surviving lamb came from a single. So how many surviving lambs have we got? Well, we've got 559 plus 140 plus 280, and 559 of those came from a single birth. So that works out to be 559 over 979, which is 0.571. Now, you could have done that with a tree, but if you've done it with a tree, let me just see if I can change pen colour. No, that's probably going to make this all go bad, but we'll give it a go. No, we're not doing that. Okay, this number here, which is for the twin births where both survive, you have to double that weight in the probability. I think it's much easier to work with a number of lambs than to try and just stick with the probabilities. So remember, in hard questions, it's fine to go backwards and forwards between a tree and a table. Now, the next question is a little bit similar. Right, this is also an excellence one, and this is looking at the lambing percentage. So here, we're told that we've got this idea of a breeding ewe, which is a ewe who's been prepared to have baby lambs, and about 85% of breeding merino ewes actually produce lambs. So the lambing percentage is the number of lambs that survive until weaning compared to that number of breeding ewes. So we're going to use the same idea here, but I'm not even going to do a table. So we're going to start with 1,000 ewes, right? So 850 of them will produce lambs, right? So the 1,000 ewes is going to be on the bottom of my fraction. Now, how many have singles? Well, 65% of those produce lambs, and 86% of those lambs survive. So that gives me 475 lambs there. Right. Now, what about the other 35%? Well, 0.35 of the 850 have twins, and 40% of those have one lamb that survives. Right, so that gives me 119 lambs. But don't forget, we've got, out of those 35% that have twins, 40% have twins where both survive. So that gives me 238 lambs. So the lambing percentage is the number of lambs that survive out of the number of breeding ewes. So we started out with 1,000 breeding ewes, and we end up with 475 plus 119 plus 238 lambs. So that works out to be 832 lambs for 1,000 breeding ewes, which gives us what we call the lambing percentage of 83.2%. Okay, also an excellence question. Now, happily, the last one is really quite easy, but it's very, very wordy. So we'll go and have a look at that now. Okay, so this is looking at a specific sheep station called Highbrook, and there are two kinds of sheep. There's merino sheep and Romney sheep. And the table gives us the proportions of each type that end up having one lamb, a single, or a multiple. Okay, so it's not focused on whether those lambs survived. It's just focused on whether the sheep had 0, 1, or 2 babies. And then what happens after the lambs are weaned, then they sort out the ewes and they send some to the freezing works and others get kept for breeding the following year. Right, so you'll notice that those numbers add up to 1 and those numbers add up to 1. Then on the next slide, we still haven't got to the question. This is the proportion of the Romney ones that were culled and kept. So here, this adds up to 1, this adds up to 1, and this adds up to 1. And you can see that the ones who were the multiple births, so the ones who had the twins, not many of those were culled. A lot of those were kept for a second year of breeding. Now, we're told in here that the ratio of merino to the Romney to merinos at the start of the year was 3:2. So Romney made up 3 out of every 5 sheep. So 60% of the farm were Romney. Right, now, at the end of the 2016 lambing season, what proportion of the total breeding ewes were Romneys that were empty, what a horrible expression, there we are, did not produce a lamb, and were culled? So we can think about this as a tree. We want to have Romney or merino lambs that produced ewes that produced no lambs and were culled. So the question boils down to a really simple little tree, and so that probability will be, I'll put it up here, what have we got? So the probability of Romney, no lambs, and culled is equal to 0.6 times, where are we? So no lambs, go back to the table on the previous slide. What was that? 0.06. And here we want the proportion that were culled, so times 0.88. So that works out to be 0.032. Okay, and that was a merit question. All right, thank you very much for persevering this far. Hopefully the sound quality is not too terrible. So let me know if there are any issues with that. Make sure that on those excellence questions you go over them a couple of days after you watch this to make sure you can do it on your own.